Okay, welcome to AMI Day 6. We're going to talk about radian measures of angles today. The first thing we need to know before we define radian measure, we need to know how to find the circumference of a circle. Recall that the equation for the circumference of a circle is 2 times pi times the radius. Since the unit circle is centered at the origin, has radius 1, the circumference of the unit circle is 2 times pi times the radius of 1, or just 2 pi. So now we're going to look at a circle. A unit circle. And we know where the 0-degree angle is, and we know that if we go all the way around the circle, that's a 360-degree angle. And so what I want you to see is how far would we travel if we walked along the edge of the circle the entire circumference. If this is the unit circle, the radius is 1, so the circumference of that circle is 2 times pi. That's the arc length of a 360-degree angle on a circle. 2 pi is how far you would walk. We are going to define radian measure of an angle as the angle's arc length on the unit circle. Therefore, a 0-degree angle, if we start here and go nowhere, the radian measure of a 0-degree angle is 0 radians. No arc length. If we go all the way around a circle, we've gone 360 degrees. This 360-degree angle has an arc length of 2 pi on the unit circle, so 2 pi radians is a 360-degree angle. If we only go halfway around the circle, that's 180 degrees, and that's only halfway to 2 pi, and half of 2 pi is just pi radians. I'm going to drop the units now, even though science teachers hate that. If we go halfway to 180, we go 90 degrees, but that's halfway, half of pi radians, and so pi times 1/2 is pi over 2 radians. If we go 3/4 of the way around a circle, 3/4 times 2 pi, it's going to be 6 pi over 4, which reduces to 3 pi over 2. So a 270-degree angle has 3 pi over 2 radians. What if we go halfway to pi over 2? Halfway to pi over 2, halfway to 90 is a 45-degree angle, and 1/2 of pi over 2 is pi over 4. So a 45-degree angle is pi over 4 radians. Now, if we go 3/4 to pi, of the way to pi, that's a 45, 40, 90, more 45 to 90, 45, 90, 135, 135-degree angle. This is 3/4 of the way to pi units. So that's 3 times pi over 4. So 135-degree angle is a 3 pi over 4 radian. I like to teach this with steps around a circle. Break this into 45-degree angles. So 45, 90, 135, 180, 225, 270, and then 45 more makes 315. And look as if we're stepping across this. So if I take one step to get to pi over 4, that's 1 pi over 4. Another equal size step takes me 2 pi over 4, which reduces to pi over 2. Another equal size step, 3 pi over 4. 4 pi over 4 reduces to pi, and this next one's going to be 5 pi over 4. So 225 degrees is 5 pi over 4 radians. Then 6 pi over 4, what we saw up here, reduces to 3 pi over 2. 7 pi over 4 is 315 degrees. And 8 pi over 4 would put me back at 360 degrees. 8 pi over 4 reduces to 2 pi. So this is a way you can find the radian measure of the 45, 90, 135, 180, 225, 270, 315 degree, 360 degree angles on the unit circle. Stepping off in 45 degree segments and knowing that each one of those segments is 1 pi over 4 units around the circumference. So we have 8 of those in a 2 pi circle. Those are the pi's over 4. We had other angles on a unit circle. We had the 30 degree and the 60 degree, the 120 degree angle, 150 degree angle. I'm putting another circle up here because it gets really cluttered when you put them all in one. I'm trying to teach this. 180, then we're going 210, 240, 270, 300, and 330. Now, the pi's over 4, 45 degree angles are still inside there. I'm just not labeling them so we can keep this clean a little bit. This is 0 degrees, and I'm going to make this unit circle, make sure it's radius 1. 0 radians. 180 degrees is pi radians, we said. 90 degrees is pi over 2, we knew that. And 270 degrees is 3 pi over 2. And of course 360 degrees is 2 pi. So now what about these 30, 60, 120, all these angles? Well, let's look at this and notice that 30 is 1/6 of the way to 180. 6 times 30 makes 180, so this is 1/6 of pi radians. 1/6 times pi is going to be pi over 6. So 30 degrees is pi over 6 radians. We could take our steps again, and we could say, that's 30 degrees, that's 30 degrees, that's 30 degrees. We can just step this circle off in 30 degree segments. And if each 30 degrees is 1 pi over 6, this is 1 pi over 6. 60 degrees is 2 pi over 6, which reduces to 1 pi over 3. 90 degrees is 3 pi over 6, which reduces to pi over 2. 120 degrees is 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6 is 150. 6 pi over 6 reduces to pi. 7 pi over 6 is the next step at 210 degrees. And then 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And 11 pi over 6 is the 330 degree angle. So now that we have all of these, we can go back and fill in the radian measure on the unit circle we did for a review earlier. We had all the angles, all the cosine and sine. So a 0 degree angle is 0 radians. A 30 degree angle is pi over 6 radians. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. If you notice my pause there, it's because I don't have these memorized. I have to figure them out every time. It's easier for me to build this circle than it is to remember this circle. 180 degrees is pi. Then we have 7 pi over 6 at 210. This is 5 pi over 4 and 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4. Again, the pause where I'm picturing stepping off in my mind. And then 11 pi over 6. And finally, 2 pi radians is 360 degrees. If we ever get back to school, I will give you a blank one of these, which I attached on your Google Classroom, by the way, and I will ask you to fill it out. On your final exam, there will be one of these blank circles, and you will have to fill in all of the cosines and sines, all of the degree measures, and all of the radian measures from 0 to 2 pi, from 0 to 360 degrees. You'll have to fill in all of this to get full credit for that circle. That is how we define radian measure on a unit circle. But what about an angle in general? Let's say we had to convert a 37 degree angle to radians, or we had to convert a 5 pi over 7 radian angle to degrees. We can write any angle in degrees in radians. We can write any angle in radians in degrees. We just need to know how. If we go back at our circle and notice that 180 degrees is the same as pi, we can set up a unit conversion ratio, and we can say degrees go to radians as 180 goes to pi. And if we flip that, we can say radians go to degrees as pi goes to 180. So if I want to convert degrees to radians, I'm going to use this ratio because my radians are in the top. That's going to make it a little easy. I'm going to let x be the missing radian measure and say over my given measure, x over 37 degrees is equal to pi over 180 degrees. When I multiply both sides by 37 degrees, I get x equals 37 degrees times pi over 180 degrees. Because units cancel, the degrees cancel, and x gives me, or x ends up being 37 times pi over 180 radians. And that's the equivalent in radians, which is just another unit of measure for angles, as 37 degrees, 37 pi over 180. If I want to convert 5 pi over 7 radians into degrees, I'm going to put my degrees on top here. I'm going to use this ratio. I'm going to let x be my degrees. I'm going to put 5 pi over 7 in the denominator, and that's going to equal 180 degrees over pi. If I want to get rid of this 5 pi over 7 in the denominator, I'll multiply both sides of this equation by 5 pi over 7. That cancels here and leaves me x equals 5 pi over 7 times 180 over pi radians. The radians will cancel out. The pi's cancel out. I end up with 5 times 180. That's going to be 500 plus 4. That's 900 over 7. And if you get that in your calculator, that would be in degrees. 900 over 7 degrees. And that's how we convert radians to degrees, and degrees to radians.